So we started into graphing, and we're going to use a table to be able to graph this function. And remember, if we have an equation y equals negative x minus 1, what we're really trying to do is we're trying to find an x and a y value that will make this equation equal on both sides. So the easiest way to do that is to make a table, and I can plug in any x number I want. And so let's say negative 1, 0, 1, 2. Those seem like good x numbers. Really doesn't matter, but they will fit on my graph if I use smaller numbers. So if x is negative 1, then I have y equals negative on my x out front. And then I'm inputting a negative 1. Minus 1. Okay, so I had the negative on the outside and I'm plugging in a negative 1. That means this negative makes a positive 1 minus 1. And 1 minus 1 is 0. So when I plug in negative 1 for x, 0 for y, that equation will be equal. So if we want to try it, so put 0 in for y, negative 1 in for x, and if you look here, this is 1 minus 1, and 0 does equal 0. So it is equal on both sides. That's what we want. We want a solution. That means it's got to equal on both sides. So next, we're going to input 0. Well, a negative 0 is just 0. Minus 1. 0 minus 1 is negative 1. So I have 0, negative 1. So when I input a 0, then this has to equal negative 1 for it to equal on both sides. Okay, I'm going to input a 1. Y equals negative, putting in a 1. A negative on a 1 is just negative 1. Bring down minus 1. Negative 1 take away 1 is negative 2. So when I input a 1, I get out a negative 2. Okay, and the last number I decided to plug in here was a 2. And a negative on a positive is just, this is negative 2 minus 1. Negative 2 minus 1 is negative 3. Okay, so I found some solutions, and I'm going to plot those. So negative 1, 0 is over left 1, and 0 is right on the axis. 0, negative 1, so I go 0 down 1. I don't know why my pen's not working. Okay, 1, negative 2, so I go right 1, down 2. And then 2, negative 3, I go right 2, down 3. So if you look at this, I've got 4 solution points. But remember, if I kept picking more and more points, my graph is going to keep expanding. I'm going to end up with more and more solutions, and even if I pick decimals, then I'm going to get solutions in between all these points. And if we keep plotting and plotting and plotting, that is going to form our line. And to show that I can plug in any number and get a ton of solutions, we draw arrows. Okay, here's another one. So we have our x and y table. I can plug in any number I want to for x. So this time, let's say negative 3, negative 1, 0, 2, 4. So negative 3, the y equals, so we got negative 2. I'm plugging in negative 3 here. Well, this means that I need to multiply those. So negative 2 times 3, negative 3 is positive 6. Okay, now instead of that, I'm going to input a negative 1. Negative 2 times negative 1 is positive 2. All right, I'm going to keep going to figure out all these solutions. So I'm going to have 0. Negative 2 times 0 is 0. Okay, I want to know what my y needs to be when I input 2. So negative 2 times 2 is negative 4. And the last one, if I plug in a 4, negative 2 times 4 is negative 8. So now I need to plot my solutions, right? These are all solutions, right? Because if you plug in, if I try the first one, if I plug in 6, and I plug in negative 3 for x, y, well, it is equal on both sides, which means it is a solution. So I'm going to graph these solutions. So left 3, up 6, 1, 2, 3, 4, 5, 6. Left 1, up 2, 0, 0. Right 2 down 4, and right 4 down 8. That's 4. Oh, my graph is 8. There it is. And again, I just have 5 solutions on my graph, but again, if I keep plotting and plugging in points, plugging in x numbers, and I keep going and going and going, right, my line, my points, my solutions are going to fill in this line. And I put arrows to show I'm showing all the solutions to that equation. So that means if I pick, say, this point right here, that would be negative 2, 4, then that should be a solution. Let's try it. X, y. If I plug in 4 for y, and I plug in negative 2 for x, is negative 2 times negative 2, 4. And yeah, this is equal on both sides. So that point that's on the line is a solution, which is what we thought, right? Because any point on the line should be a solution. Well, now if I pick, let's say, this point here, that would be 4, negative 1. Is that a solution? Well, let's plug in negative 1 for y. I'm plugging in 4. Well, negative 2 times 4 is negative 8, and that's not equal, which means what this is saying is any point on the line is a solution, because we're showing the solutions on the line. Any point not on the line is not a solution to this equation right here. All right, again, let's make our table. I'm only going to pick 3 points this time, so how about negative 3, 0, and 2. If I plug in negative 3 for x, I need to know what y needs to be. So this negative 3 and negative 3 make 9 positive when I multiply. So y has to be 9. Then I'm going to plug in a 0. And anything times 0 is 0. And the last one, I'm going to put in a 2. And 3 times 2 is 6. And a negative on there, because there's only one negative. Okay. So now I'm going to graph these. I go left 3, up 9. It's 1 off my graph, but that's okay. 0, 0. And then 2 down 6. Should be right here. Okay, so I do only have 3 points, but again, remember that if I were to do more and more x numbers and plug them in, so I could keep going, right? I'd get negative 3 if I times that by 1. So 1 down 3. I could keep going and plug in more, right? But what would happen here is it'd start filling in this, right? More and more solutions. It'd start filling in because you have so many that we end up with this line. So again, let's think about this. If I have, say, this point right here, which is called negative 1, positive 3, let's try plugging in that x and that y. So x, y is 3, x is negative 1. If I times those out, I really do get positive 3, and it is a solution. So any point on the line is a solution. That's what we're showing. All right, x, y. How about 0, 1, 2? If I plug in, so y equals 2, 0 plus 3. 2 times 0 is 0, plus 3 is 3. Next, 1. 2 times 1 is 2, plus 3 is 5. And a 2. 2 times 2 is 4, plus 3 is 7. Okay, so I've got some solutions I'm going to graph. So 0, 3, 1, 5, and 2, 7. And again, if we were to keep going here, we'd fill in this line, draw arrows to show all the solutions to this equation. All right, here, I'm going to pick numbers that are a multiple of 2 because it makes it easier. So I'm going to pick negative 2, 0, 2. And here, if I plug in 1/2, I'm plugging in negative 2. Half of 2 is 1, so this becomes negative 1, minus 2. Negative 1 take 2 is negative 3. Next, 0. Anything times 0 is 0, plus 2 is 2. And then a positive 2. So half of 2 is 1, and 1 minus 2 is negative 1. All right, so I've got some solutions I'm going to graph. Left 2, down 3. Start at 0, up 2, and start at 2, down. Uh-oh. Something happened. Oh, I see what it is. Okay, when I plugged in 0, 0 take 2 is negative 2, which I need to get rid of that. So down 2. And then 2 down 1. All right, so if I were to fill this in with more and more x values and figure out the y values, it would make this line, and there's my solutions. Last one here. How about, negative 1, 0, and 2. So I'm going to plug in negative 1. Let's see, this is positive 2. Take 6 would be negative 4. All right, 0. Anything times 0 is 0. Take 6 is negative 6. And 2. Negative 2 times 2 is negative 4. Take 6 is negative 10. Well, that's off my graph, but that's all right. Okay, so I'm going to go left 1 down 4. I'm going to go start at 0 down 6. And if I were to go 2 down 10, it'd be somewhere down here. And then I have to show all the solutions by connecting and filling in that line.